as we roll into this quiz preview, which again, mainly exponent rules, if you haven't at this point, make sure that you have checked out the lesson from yesterday if you missed, or a little later today when I post these on the front page of Classroom, that you've got your exponent rule. But this is actually our notes for this unit so far. Lots of plain examples, lots of having these things up. I'll freeze this back up on the screen when we're done with the preview to make sure that we've got this and it's under control, okay? So, for the time being, though, I'm going to slide this down a little because I want us to be able to see the questions as we're starting on page 3 of the packet here. Well, if you want to call it that. So, simplify the expression. No decimals. I'm going to add something to this. This is in that little mini practice packet. I'm just keeping the notes available to me. There's no new notes today. We're just going to use them to help us. So, when we're simplifying with exponents, okay, no decimals ever. We got math enter for that. Excuse me. And we never have negative exponents in answers. So, if I'm looking at something and I see a negative exponent, and I do here, we talked yesterday about how we can flip them, put them in a new place, put them with a new background, and they can enjoy things. They're very positive about stuff. So this x to the negative 5th is going to flip and join the 7 up in the numerator. To which the question then from people is, well, if that's true, then what's left in the denominator? Because that went up to the top. I can either put a 1, or I can just leave it as 7x to the 5th because we assume the 1 is there. That's it. I did one flip, I'm done. Okay, we're keeping life simple. The one thing that we talked about in passing, but we did not put on our help here with our notes yesterday. Again, those of you kind of playing to speed right now, the page 3 here is the actual practice packet. The stuff that you see on writing in the bottom is the Unit 7 notes we started yesterday. There was one piece I didn't put on here, but we're going to squeeze this on here now. We're going to squeeze here. Anything to the 0 power equals 1. So when I say that, for those of you that are in here, so if I tell you that it's x to the 0, that equals 1. If it's 5 to the 0, that equals 1. If it's a squared, b squared, x, y, z to the 17th to the 0 power, it's 1. So, the reason I mention that, while you may be jotting that down and adding that into the note area, is I start to work my way along. Now, I see negative exponents again. So I know we're going to need a fraction here. So I start to go. First rule, again, remember, big numbers, the coefficients, this -6, doesn't play by little number rules. In other words, wait a minute, I don't flip that? No, it doesn't have an exponent. Leave it alone. X to the 9th is behaving itself. Leave it alone. Y to the -3rd, though, is not behaving itself. It needs to be flipped down to the denominator to get that value situated. And then z to the 0 is 1. It just goes away. Because me taking that and turning it into 1 and putting it here does not change anything. It doesn't make it bigger, smaller, it does nothing. So it's just z to the 0 just up and walks away and disappears. All of my values have positive now, and we're off and running. As long as I don't have negative exponents and everything is combined, I'm good. So I kind of keep playing that way. When we get up here, I'll say it again. Big numbers don't play by little number rules. Okay. So negative 2 times 8. Negative 16. Just multiply them together. Then I look down. Okay, now with my x's. When we're multiplying exponents together, which we are right here and right here, we're going to add the exponents. So x to the 2 plus 9, which would be x to the 11th. I'm done. No negative exponents, no flippage needed, nothing else to combine. We're set. And so as you keep playing, oh, excuse me. So I look and I go, okay. Now I see parentheses. Now what's that again? Parentheses is power to power. You know what? Let's do this. I'm going to put parentheses around power to power to remind me that's what it means. When I see that, we're going to multiply the exponents together. But as we mentioned yesterday, if you're looking at your note sheet as we go here too, it's just like number 4. That 3 is going to go to both the 6 and to that x to the 4th. So I'm going to have 6 to the 3rd and x to the 4 times 3. Reminder, 6 to the 3rd power is not, ooh, that's crazy right there. Okay, is not 18. It's not 6 times 3. 6 to the 3rd power, there's our exponent button. That's much bigger than 6 times 3. And then multiply your exponents together. Keep life simple. Just those 2 basic steps and we're going to be okay. And you kind of keep looking, you're like, there are a lot of the examples on here that are on here. Is this really as long as the quiz itself is going to be? It is. It is. So I keep looking. Coefficients. They just do normal stuff. What's 20 divided by 4? I thought I heard it. 5. Okay. What exponent's on a variable when I don't see one? 1. So there's my x's. Okay. When we divide, we're subtracting the exponents. So we got 5 minus 1 for x. We've got 7 minus 4 for y. And again, I still have to simplify it. And we're set. Straightforward as that. Now, once we hit number 6, though, now we got to start making some decisions. Because we're going to have options. So we're like, okay, we got this. Big numbers don't play little number rules. We're going to multiply. Okay, 7 times 3 is 21. Now I've got negative exponents. Could I still add those up and go from there? I could. So let's try that. So what do I get if I add 5 and negative 7 together? So I got negative 2. So I'm like, okay, x to the negative 2. And then I do the same thing with my y. 6 plus negative 4. You're like, could I do 6 minus 4? You could. I get y to the second. Now, if all the exponents were positive, I'd be done. I'm good. But they're not. So we got to fix that. 21 is behaving itself. Leave it alone. X to the negative second is not behaving itself. It is acting negative. We don't like negativity. We want to make this positive. So we're going to do positive 2. And we're going to leave the y squared alone because it's positive. Don't flip the positive stuff. You know, if that variable's doing the right thing, leave it alone. And once everything's positive, we're happy. They're happy, they're positive, we're happy, we've got the right answer, and we're all right. And so we play that back again. We kind of use 4 as our example. So this 2, it's going to go to the 4, and to that 6, and to that negative 5. Six times 2, negative 5 times 2, and if, again, that causes you trouble with any of these, punch them in the calculator. You are not going to get extra credit for coming up with stuff in your brain. 4 squared is 16. It's positive, don't do nothing. But if you're negative, we're going to fix you. And we're going to get you set. And make it better. So, for my people who like consistency, you like to do things the same way each time, quit throwing me twists, quit throwing me all these things I need to do. We're going to do number 8 the exact same way we did 7. But for those of you that are like, well, wait a minute. Could I flip this whole thing right away since it's negative and put all of it at the bottom of my fraction? The answer is yes. You have an option. But since this is kind of new and we would still have some negatives, I'm going to suggest that we keep going and doing what we've been used to, because it's going to be easier for us. So I've got 3 to the negative second. Here, I've got negative 4 times negative 2. Do not lose track of those signs. My y's, negative 7 times negative 2. Because just by doing that distributing, a lot of the negativity went away. Those are positive now. So, there's a couple of ways I can deal with this 3 to the negative second. I could flip it down to the denominator. You're like, wait a minute. I thought big numbers didn't play by little number rules. They don't, but that's still an exponent. The exponent's still got to play by our rules. X to the 8th is playing by the rules. We'll leave it alone. Y to the 14th is playing by the rules. I'll leave it alone. You're like, I don't see any more negative exponents. I'm done. If it's a number, I want you to simplify it, though. So 3 to the second power, 3 times 3 is 9. Okay? No negative exponents. And we're set. And so the last one I start to look, I'm like, okay, 8 divided by 20. Now, wait a minute. 8 divided by 20. 8 divided by 20 is a decimal, but no decimals. How do we fix no decimals? Math. So right here below alpha, math, and 2 enters. It's a fraction. That's okay. I can make a fraction. Okay, let's put 2 over 5. But for everything else, I'm going to play by the rules. You're behaving yourself, x to the 6th. You get to stay. Oh, y to the 5th, not behaving. Denominator, you go. But you become positive when you get there. So see, we just needed a different learning environment, and it would be okay. I've already dealt with the 8 and the 20, so I don't have to deal with that. X to the negative 4th is not happy down in the denominator. But up in the numerator, it is. So it's much more positive. And y to the 2nd is perfectly content down in the denominator, so we're letting y to the 2nd stay.
How is it x to
He's pondering. Once I've done all my flipping, I've made my y to the negative 5th and my x to the negative 4th positive. Now I got to go back to my rules here. Just a second. Let me move that. If, and I'll show that here in a minute, you have an option on this one. If we get rid of the negatives first, though, now the x's ended up on the same level. So we're multiplying, so we add their exponents. And the y's ended up on the same level, which is multiply. So we add their exponents, and we're good. But for the question here on, well, wait a minute. The original problem, it looks like we're dividing, so why aren't we subtracting? That doesn't seem right. Okay, I'm going to put my note card next to it here, which means, again, what we did is fine. So I have my 2 over 5. We did our math enter. I could do x to the 6 minus negative 4. I could do the division. I could do y to the negative 5 minus 2. That would be okay. I could do that. And so if I did 6 minus negative 4 would be 10. Negative 5 minus 2 would be negative 7, but the negative, we don't want our variable to be unhappy, so we'd flip the negative 7 to the bottom, and I get the exact same thing. So as long as you're following the rules, it doesn't matter which rules you're using, as long as you're following them, you're going to get to the right answer either way. Now, I said most of this quiz was going to be exponents. Not all of it, though. Little left on the back here. So, I get here to the back and notice it's Unit 6 stuff. Unit 6 notes are still in play, people. It's our chance to be able to fix up things. Or for some of you that need to do a retake or the original quiz for quiz 2, here's a good chance to see this again, where it hopefully cleans it up for you. So set up the system, solve a short break-even problem. Okay, it literally is telling me what type of problem I'm looking for here. So I'm going to move this down a little because I can get my help in this way. Okay, on the top is my Unit 6 notes for break-even. So you have opened a cake-making business. So that sounds good. Your cost to open and equip your shop was $200. Your cost was $200. Not $200 a day, not $200 a month, one time. If every cake costs you $4, put the X with it, Every cake, again, cost to make, and you sell them. Revenue, sales, same thing. For $30, oh, there's the magic word, each. See, we got it right there. Each are per X. Okay. That's your equation.
We have to solve it.
We still have to, yeah, it didn't say just set up. We have to solve it.
What is this?
But you've got it right here. If seeing this isn't helping you, it's because you were doing something else during the original lesson, or you weren't here and you never took 5 seconds to go back and look at it. Use the tools or take the natural consequences thereof. This is set up to be like homework assignments. So, what did I do up here? I got everything to the side with just X, so let's do that here. Let's move that 4X to the other side. Let's minus that over, and then we just divided by what was with X. So let's see here. Hardy, I got a decimal. Something must have been wrong. It's not. It's not. So you're like, well, wait a minute, though. So let's just write this down for a second. Okay. How many cakes must you sell? So let me ask you a question. Have you ever gone into a place to buy a cake, a cupcake, whatever, and said, hi, I would like to buy 0.69 of a cake today? They'd look at you like you were nuts, because you probably would be. So, for me to break even, round up. Okay? It depends on the situation. If it was money, we can do money and cents. But this makes no sense. So, work it through. Now, you're like, well, what if I put that on the quiz? What if we had a quiz question like that, I put 7.69? I'd write a funny little comment, and I'd probably ding it for like 1/2 out of 4. I mean, it's not going to be anything terrible. But it's the same thing. Okay? Moving on up. Set up only, we're just making equations on this one. At school, the cost for 2 cookies, I'm looking for my examples. Oh, here we go. Okay. And 3 Husky burgers is $5.50. Dang, that'd be a good bargain. The cost of 5 cookies and 1 Husky burger is $4 in a sugar rush. Write a system of equations to model this. Okay, so I notice each sentence has cookies and a Husky burger. So I'm looking for help again. So I'm bumping this up, and I'm looking at my notes again, right in there. Here's one where we were talking about buying fudge and bubble gum, and fudge and bubble gum. And each sentence told me an equation. So we're going to follow that, and we're going to do it here. The cost for 2 cookies and 3 Husky burgers is $5.50. Okay, so 2 cookies and 5 Husky burgers. No, Hardy, I'm trying to eat more than I need. 3 Husky burgers is $5.50. Okay. Following the sentence, just like we did in the example. The cost of 5 cookies and 1 Husky burger is $4. You're like, wait, we had to solve it down here, but here it says set up only. I'm done. I'm done.
Oh, easy.
Keep it simple. Do I have any? I got examples left. I got one left. So the system of inequalities is what we're going to finish up with. We have help for that too. It's just the back part of my Unit 6 note packet, which is still posted on Classroom if you need to update them. Graph the system of inequalities. Be sure to graph dashed solid lines and shading.
What's a dotted line?
That's a good question. So, I look, and I'm going to say it again. Okay. Here's my help. I can't really fit it on there. But I have all the information I need for dotted and solid lines. How do I shade? Where do I shade? If you need help on graphing the lines, because that's your problem, same note packet, y-intercept, rise over run. What direction do I go? They're there. If you're not going to pick up a pencil and look to see that they're there, again, I can't feel bad. I'm working on that. I mean, I do, but I don't. So, I'm going to graph this. My y-intercept is at -4. Watch signs, they matter. My slope is 1/2.
Make sure one's dead.
From here, up 1, right 2. Up 1, right 2. As long as you've got at least 3 dots, you're good. Okay, now, again, we're going back to the making fun of Hardy time. I'm okay with this. Here's my notes back. My arrow does not have a line underneath it. We're going to be dotted or dadded, as I said earlier. So I'll make my dotted, my dashed line. The arrow is eating y, which means it's greater than. If y is greater than, we shade above. So, okay, so my purple, that's all you've got to do for shading. I don't need to do it real deep because I need to see more where they intersect here in a minute. So, second line. Same idea. Y-intercept, y-axis. If it's not a fraction, make my slope a fraction. Down 2, right 1. Down 2, 1. I'll do a few more. Now again, the lines themselves do not have to have an intersection point. We're just looking for what the shading does. So, I look again, my line does not have anything underneath. It is still dotted. Yep, true. Again, colors are helpful on this. That's why I have all the markers and the colored pencils in the back. This time our arrow is pointing at y. When that happens, we're shading below the line. So again, I get that in. But I don't just leave it now. You have to show me where the intersection is. I don't want it where it's just purple. I don't want it where it's just red. I want it here where I'm seeing, our check with both. So whether you just kind of make a deep outline for me like this, that's fine. Or if you want to shade it a little more, you can. But that's it. And I say this every time. You know me with these quizzes. We just did the quiz, basically. I just changed numbers. So if you haven't finished your practice back in Unit 6 on inequalities, on word problems, do them. If you haven't finished the practice from Unit 6 on exponents, you got some more to go back and do. If the confusion is this, watch this again and play with some. Check your answers. You've got to start doing some things differently, some of you. If you keep doing the same thing, you're going to keep getting the same result. I can't fix that. So, with that, we will bring this one to a wrap. Again, next time I see you, we're quizzing on this. So be ready. I'll have this video posted. I'll have the notes posted. And we'll take it from there.